Hey calculus students, we're here in section 7.2, verifying solutions for differential equations. We're looking at for what values of a will y equals a sine 2x plus 4 cosine 6x be a solution to the differential equation shown below. So what we're going to do on this problem is start taking the first and second derivative. Normally you don't want to look at a problem and just wonder what you're going to do. Let's start just taking derivatives first and second, see what happens. So I'm going to have y prime is going to equal sine 2x's derivative would be cosine 2x times 2. So we're going to have 2a cosine 2x. We have that extra 2 because of the chain rule. And then we have minus, because the derivative of cosine is negative sign, and we do have a chain rule on that 6x, so we're going to have minus 24 sine of 6x. It looks like the differential equation that we're working with does not have y single prime in it, but we need to find that in order to find y double prime. So y double prime, so take the derivative now, and derivative of cosine is negative sine. So we're going to get negative 4a sine of 2x. And then we're going to have another negative. This time, though, derivative of sine is cosine. We would chain rule on the 6. 24 times 6 is 144. So we have minus 144 cosine of 6x. So we have now our second derivative that we're going to use along with the original function y equals, and we're going to plug them in then to our differential equation and then solve for a. Alright, so we're going to have 2 times y double prime. So that leaves me negative 8a sine 2x. And then minus 288. Sounds nice and big, but we're just going to go with the flow here. 288 cosine of 6x. And that's 2 times y double prime. Then we need to take 72 multiplied by the original function y. That will leave us, 72a times sine 2x. And it looks like it works out perfectly because 72 times 4 is positive 288 cosine 6x. And that's my whole left-hand side of the equation. So I'm going to clean that up before we move on any further. We'll cancel out these two terms. And then I'll combine my other two terms. And it looks like I'm going to have a 64a sine 2x. And that's going to be equal to my right-hand side, which conveniently also has a sine of 2x, negative 10 sine 2x. At this stage, we could divide both sides by sine 2x, divide both sides by 64, and you get a is equal to negative 10 over 64. Or reduce down to divide by 2 on top and bottom, negative 5 over 32 as my final answer.